Good morning, friends, and welcome to another fun-filled day of Math with Miss Ross. Thank you for those of you who submitted questions on the answer garden yesterday. Most of you did a really great job with that, and I was able to see that some of you are feeling really confident with metric conversions, some of you are okay, and some of you are still confused. One question that I saw a lot of was, why are we learning this? Which is a really great question. We kind of jumped into it without really talking about why we need to be able to convert measurements. So today we're going to look at some real world problems to hopefully help those of you who say, why do I even need to know this? And also help those of you who are still struggling a little bit with metric conversion. Another question that I saw had to do with why do the chants work the way that we do? Why do we say big to small, multiply them all, small to big, divide the pig? So just a real quick answer to that question. If you're going from a big unit of measurement, like kilograms, to a smaller unit of measurement, like grams, in our chant, we would say big to small, multiply them all. And the reason why we're multiplying is because it's going to take more grams to fill the same space that 1 kilogram would fill, right? So 1 kilogram, which is, I guess, technically weight, 1 kilogram is 1,000 grams. So it's going to take 1,000 grams on a scale to be the same weight as 1 kilogram. So when we're trying to convert from kilograms to grams, we multiply because we're going from a big unit, which just takes a few to get the correct weight, to a smaller unit, which is going to take a lot more to get to that same weight. And the same thing for small to big, divide that pig. If we're going from a smaller unit of measurement to a bigger unit, it's going to take less of the big units to do the same thing as that small unit. So we need to divide that number to convert it up. Hopefully that makes sense a little bit more. If not, let me know and I'll see if I can explain it in a different way. Okay, so today we're going to look at some real world problems to help you see why do we need to know about metric conversion to begin with. All right, so the main reason why we are learning about metric conversion is because sometimes in the real world, measurements don't always line up the same. We might be given something in one measurement and need it in a different measurement. So let's look at what I mean by that. Okay. So in this problem, it says, Michael's mom bought 2 liters of soda for his party. His dad bought cups that hold 25 milliliters. How many cups can Michael fill up for his guests? So we can see right here in the problem that we're talking about 2 different units of measurement, right? Michael's mom bought soda that's measured in liters, but his dad bought cups that's measured in milliliters. So right now, when we're trying to figure out how many cups can Michael fill up, we can't do anything with the problem the way it is. It's like having apples and oranges. It's 2 different things. So before I can figure out how many cups, I have to first make sure that my units of measurement are the same. And this is where conversion comes into play. I either need to change my liters to milliliters, or I need to change my milliliters to liters. And it really doesn't matter which way you want to do it. I will typically go big to small, multiply them all if I can, because multiplication is quicker for me than division, but you do what works for you. Okay, so I'm going to turn my 2 liters into milliliters. So I'm going to write my equation first. And then I'm going to get my stair steps. Some of you say you like the stair steps, some of you say you don't, and you would rather use like the straight across method or just use memorization. That's fine too, but I'm going to continue to use the stairs. Well, that was a weird stair. I'm running into the video. All right, so King Henry died while drinking chocolate, milk. Okay, so I'm, starting with liters. I thought that looked weird. Starting with liters. Oops, look at that. I said while drinking chocolate milk. It It should have been by drinking chocolate milk. Okay, now I'm ready to go. So liters is my base unit. Milliliters is down here. We're going from big to small, multiply them all. So I'm going to take my 2 liters and I'm going to multiply it. I'm going to multiply it 1, 2, 3. 3 hops equals 1,000. So I'm going to multiply it by 1,000. 2 times 1,000 equals 2,000. So 2 liters is the same thing as 2,000 milliliters. So when I go back now to my problem, I can take this out and I can replace it with 2,000 milliliters. So now the problem reads, Michael's mom bought 2,000 milliliters of soda for his party. His dad bought cups that hold 25 milliliters. How many cups can Michael fill up for his guests? So now I have the same units of measurement, so I can actually now solve this problem. I have the total amount of soda that Michael has, 2,000 milliliters, and I also know that he's going to be taking that soda and pouring it into cups that hold 25 milliliters. So as I imagine this, I can see myself dividing out the total amount of soda into groups that hold 25 milliliters. So I know this is going to be a division problem. So I'm going to go ahead and clear my workspace. And I'm going to do this division problem. So we're going to take 2,000 milliliters and we're going to divide it up into 25 milliliters. So 25 can go into 2 0 times. 0 times 25 is 0. Subtract and you get 2. 2 is less than 25, so we say bring it on down and bring it on back. 25 can go into 20 0 times. 0 times 25 is 0. Subtract and we get 20. 20 is less than 25, so we say bring it on down and bring it on back. We say how many times can 25 go into 200? Well, if you imagine 25 as quarters, which I will always do because it helps me, the 200 would be your $2. So how many quarters does it take to make $2? Well, I know 4 quarters makes $1, so 8 quarters should make $2. Let's see if we're right. I'm going to go over here to my scratch work. 8 times 5 is 40. 8 times 2 is 16, 17, 18, 19, 20, and we are correct, using that money knowledge to help me with division. So I'm going to put 8 on top. 8 times 25 is 200. Subtract, and you get 0. But we're not done because we still have this 0 to bring down. So because 0 is less than 25, we can say bring it on down and bring it on back. 25 can go into 0 0 times. Finish the problem out. No remainder. Happy face. Ooh. All right, so we have in this answer of 80, but we have to know what 80 represents within this problem. So let's go to the question. How many cups can Michael fill up for his guests? So we would say, oh, that's going to be super big. Let's take that font size down. Michael can fill up 80 cups for his guests. And there's our final answer. So you can see why we needed to be able to convert our units of measurement. Without converting, I could not have solved this problem. Let's look at another one. Ooh, pretty. Gabby and Michaela want to make identical friendship bracelets. Gabby cut a piece of string that was 15 centimeters long. Michaela's string is 15 hundredths meters long. How much more string does Michaela need in order to have the same amount as Gabby? All right, so in this problem, we can see that we are talking about centimeters and meters, not the same unit of measurement. So before I could even think about solving this problem, I first have to make sure that my units of measurement are the same. This is where conversion will come into play. We have 2 pieces of string, but they were measured in different ways. I need to be able to convert so that the units of string, or the string, is measured in the same way. So I can either change centimeters to meters, or I can change meters to centimeters. And again, I always like to go big to small, multiply them all. So I'm going to start with the big unit, which is the meters. So I'm going to set up my conversion equation. 1500 meters equals how many centimeters? And remember, I'm changing it to centimeters because that's the other unit of measurement in my problem. All right, I'm going to make my stairs. King Henry died by drinking chocolate milk. Okay. I'm going from meters to centimeters. Meters is my base unit, that's here. Centimeters is down here. We're going big to small, multiply them all. So I'm going to take my 1500s and I'm going to multiply it. I'm going to multiply it by 1, 2 hops gives me 100. So I'm going to multiply it by 100. I'm not going to come over here and set up a multiplication equation because I'm going to remember that 100 is a power of 10. So I can just say, is that a power of 10 I see? Then all you got to do is listen to me. There's only one rule. That's not a lot. All you got to do is move that dot, multiply to the right, to the right, to the right, divide to the left, to the left, to the left. We're going to hop 2 times for the 2 zeros. 1, 2. My decimal now goes there. I've turned 1500s into 15 wholes. So 1500s meter is the same thing as 15 centimeters. So I can come over here, cross that out, and I can change this to 15 centimeters. So let's go back to the problem now that we have our units of measurement the same. Gabby and Michaela want to make identical friendship bracelets. Gabby cut a piece of string that was 15 centimeters long. Michaela's string is 15 centimeters long. How much more string does Michaela need in order to have the same amount as Gabby? Well, this just turned into a really easy problem, but we might not have known it was easy had we not converted our measurement. So let's type in our answer. Gabby, hello, why are you not typing? Whoa! Gabby and Michaela have the same amount of string. There we go. The answer to our question. So again, you can see why we need to convert in the real world.